Okay, so you are going to complete the thermochemistry review today in class. If you didn't get time to finish all of them, but still you have to turn that in, I'll give more time next class. Okay, so for the first question, you are going to draw a potential energy diagram, and you have to label all reactants, products, activation energy, and then include the calculate delta H and activation energy. EA is activation energy. Okay, then predict, just tell me whether it is X or Endo. Okay, then second question, you are going to write thermochemical equation. So I'm gonna do one question for you, then second question you have to do. It says methane, the formula is CH4. CH4 gas react with oxygen gas and produce carbon dioxide and water. Both are in gaseous state, we know that. And it is releasing 890 kilojoule. If it is releasing, that means XO, you have to include energy as a product. Okay, then balance equation, there are 4 hydrogens, so I'm going to write 2. So total there is 4 oxygen. I will multiply with the 2. So do the same question, there is one more there, do that. And for this question, you are going to sort this into endo or exo and explain why you selected that answer. Say for example, melting of ice, I would say endothermic. Then I would say why it is endothermic, because it absorbs heat. So delta H is positive, that is why endothermic. So then complete all of this. Then this is a question you might have seen on your PC. So there is one question which is directly given in kilojoule, another one is in calories. So I'm going to do the difficult one which is in calories. Okay. So it says you have to read the food label, and there will be always 1 gram given there and 1 energy value given there. That is your conversion factor. So it says if you eat this, you from 40 gram you will get 130. It is a big calorie. Okay, 130 calories. Now look at the question. It is asking calculate the energy in joules. Okay, calculate the energy in joules when you consume 75 gram of the food. So we will start a T chart which says 75.0 gram of the food. Okay, then as per the conversion, if you eat 40 gram, I would put 40.0 to keep on. You don't need to worry about all 3 sig fig. 40 gram of food will give you 130 calories. Okay, then it's a big calorie, so that is always faking us. You have to think about it. So I'm going to convert. The conversion factor is given there. 1 big calorie is equal to 4180 joules. Then multiply everything and write the answer in 3 sig fig. Okay, then same thing for the next question. Here it is easy because it says 94 gram, and since calories and kilojoule is given, I would use the kilojoule value and convert. You can write the answer in kilojoule, that is okay, because no, you have to convert that into joules. Okay, you have to multiply that with 1000. 1 kilojoule is equal to, we already know that it is 1000 joule. Use that conversion at the end. Okay, so do that right now. You can pause the video and do it, then continue, or just watch the video until the end, then do the questions. Okay, then heating curve, it says you have to draw a heating curve. You are starting from ice and ending in steam. Okay, so you have to draw that curve. So I'm not gonna draw it here. You have to draw that. The starting temperature is -20, then you will reach steam in 100 degrees Celsius. Okay, then so this will be the graph look like. So this will be water, sorry, melting, and this will be solid. Okay, and this will be liquid, and this will be steam. Okay, so you have to find Q1. Okay, so Q1 we will start from -20 degrees Celsius, and the freezing point or melting point of water is 0 degrees Celsius. Calculate Q1 using the equation m times c times delta T, because there is a temperature change. Okay, then Q2, you reached 0 degrees Celsius ice, then you are converting into water at 0 degrees Celsius, which is called melting or fusion. Then you are going to use Q will be equal to m times delta H of fusion. Okay, use the formula sheet for finding the value, which is 334 kilojoule. Okay. Okay, so cover water showing heat of, okay, I will include that 35 gram of water. Okay, I'll include that when you get the formula sheet. Okay, so then Q3, you have to heat the steam to 100. We have multiple step. Okay, let me erase this. We need more space. Okay, Q3, now you have water which is at 0 degrees Celsius. You will heat the water from 0 degrees Celsius to what? 100 degrees Celsius. Again, you are using m times c times delta T. And when you use a specific heat, very careful. Here the C is C for ice. Okay, you look at the formula sheet for this value, and this C is C for what? Water. We all know that value, 4.18. Okay, then Q4, now you have water at 100 degrees Celsius. Then you are converting that into steam at 100 degrees Celsius. So temperature is constant. That means we are going to look, that is called boiling. Okay, so you are going to see m times delta H of vaporization, and after that the total energy change will be Q1 plus Q2 plus Q3 plus Q4. That's how you have to do. So same strategy, use this for this question. Okay, next one, it is asking a bound enthalpy question. So it says pentene. So I'm going to write the formula C5H10 plus O2 giving CO2 plus H2O. First balance it. There is 5 carbon and 5 oxygen. Sorry, 5. Okay, so I'm going to multiply this. There will be 10 CO2. And there will be 10 water. Okay, so 10 times 2, 24 plus 10, 34. That will be 17 or 2, right? Okay, let me check whether it is correct. Yes, 20. Yes, oxygen is 24 plus 10, 30, 34. Okay, so now first you have to make a balanced equation for that. Then draw the diagram. It is pentene. Remember the video we watched, we explained in class 2. Okay, ene means that is one carbon is double bond. So there are 5 carbons. So I'm going to draw 1, 2, 3, 4, 5 and make the first carbon double bonded. Then complete the rest of the valencies using each carbon need 4 bonds to connect it. You can draw top or bottom, I don't care. But the bonds needs to be shown correctly. So it is 3, 5, 8, 3, 5, 7, 10. Okay, that is right. Then oxygen is O double bond O, and remember there is 2 this and 17 of this, and then 10 CO2. CO2 is C double bond O. Then there is 10 of that plus 10 water molecule. Okay, now you have to, the formula we are using, we have to find the bond enthalpy of reactants minus bond enthalpy of products. You have to add all of them and then subtract. Okay, so now I don't have the bond enthalpy here. I'll go show you what are the calculation. Okay, so look, 1 2 3 4 5 6 7 8 9 10 CH bond, and it is 2 times. So you will multiply status quo 2 times whatever the value of CH plus, not 2, this is 10 times 2, that is 20. Okay, next one, there is 1C single bond B times 2, that is 2C double bond C. Okay, plus there is 1 2 3 single bond, 3 times 2, it is 6, that is single bond C. Okay, plus there is 17 O double bond O. Okay, you will add all of this, then subtract. There is CO, there are 2 COs, 10 times 2, that is 20 C double bond O, plus same thing 1 to 20 OH. Okay, once you do that, there is one additional step that we did discuss in class. Since it is 2 mole, the question is asking 1 mole. So whatever answer you are getting, you have to divide with 2 to get the final answer. Okay, and try the next one like the exact same strategy. Okay, this question you have to use stoic. Okay, there is, we'll check whether the equation is balanced. I would say this is balanced. Then says 1 mole of calcium carbonate decomposes, it forms this much energy, but we have to find 75 gram. So you will start a T chart. Always the given number will go on the top left corner, and to find the molar mass of calcium carbonate, I think 100.69, I don't have a periodic table right now with me. So you add all of them, that is 1 mole of calcium carbonate, right? Then 1 mole of calcium, this is only 1 mole. If it is 2 mole in the equation, you have to change that. 1 mole of calcium carbonate is producing 170, absorbing 178 kilojoules. Okay, then calculate, that's it. Okay, now the same here at this time, it is this equation, it's the same number, do the strategies like that. Okay, then the phase diagram. Okay, phase diagram of ammonia is given here. Ammonia is given here, so you have to answer all the questions. I'm not doing on any of this question because they are all really easy. It's asking, you can label, this is already labeling is given liquid and gas, because ammonia, it's not like water. Okay, we know that ammonia is a gas at room temperature, that's why it is different. Okay, so and there is critical point is given there, triple point is given there. So you have to answer all of this question. Once you are done, you have to submit the paper to the teacher. Okay, that's it.